Computer manufacturing refers to the process of creating the physical devices that run software and store data. This involves various stages, including sourcing raw materials, assembling components, and testing final products. These processes are complex, not only due to the nature of the technology itself, but also due to the environmental impact of the materials and energy used in this process. An example of the environmental impact of computer manufacturing is the use of rare earth elements. These materials are crucial for making components such as screens, magnets, and batteries. Mining these elements often causes significant environmental harm, including soil erosion and water contamination, which negatively affects nearby ecosystems and human communities. This topic relates to sustainability, as it demands careful consideration of how resources are used and reused. It also connects to environmental issues, because many different stages in the production process can lead to pollution and waste. In the realm of information technology, manufacturing underlies all other aspects of computing, since it impacts the availability and performance of the digital devices that are central to modern life around the world. The manufacturing of digital technologies plays a vital role in shaping sustainable practices. For instance, refurbished electronics can significantly cut down on e-waste. Companies such as Fairphone focus on designing modular phones that allow users to replace parts easily instead of disposing of entire devices. This shift reduces the number of new devices that need to be manufactured, which in turn lowers the demand for raw materials and energy, leading to less environmental degradation. Students interested in technology might explore 3 key topics related to computer manufacturing. First, material recovery focuses on reclaiming valuable components like gold, copper, and rare earth elements from outdated devices for use in new products. Second, innovations in energy-efficient manufacturing processes can help reduce the carbon footprint of producing computers. Finally, the intentional removal of unnecessary features, such as eliminating built-in obsolescence, reducing excessive packaging, or replacing resource-intensive components with simpler alternatives, can transform how systems are designed from the ground up, leading to products that require fewer materials and consume less energy throughout their life cycle.